Here we are picking up from where we left off in this example here, where we solved on an interval between 0 and 2 pi. We found 4 answers: pi over 2, 3 pi over 2, 7 pi over 6, and 11 pi over 6. We had a finite number of answers. We're going to have, in this part of the problem here, the directions are going to change a little bit. We're going to find all radian solutions. So it's just continued from that up there. Let me just grab my highlighter. So the question, the main question, is solve that equation on the interval 0 to 2 pi. Whereas here, oh boy, this highlighter, time for garbage. This part over here is find all radian solutions. So it's just sort of reworked it a little bit. And we're just going to pick up where we left off. So if I'm already at this answer and I want to get every single answer that lands in that spot, what amount could I add or subtract to keep landing in this spot? If I start here, how much could I add as an angle measure and land in this same place?
2 pi.
Right. But since this one is exactly in opposition to this one here, they are polar opposites completely across, perfect, directly across each other. Instead of adding 2 pi and writing 2 equations, the yellow angles, these ones right here, I could add how much instead and just write 1 equation.
Pi.
Right. So I could just go from there to there, and I know pi is between, instead of going all the way around for each of them and putting 2 pi in between. So for this, I'll color it in yellow, but theta equals, pick one of the angles. It does not matter which one, as long as it lands either up top or on bottom. You could even do negative pi over 2 if you want. It doesn't matter. So theta equals pi over 2 plus pi n. Now above my answer, I'm going to write n is an element instead of integers once. And I'll put that in my answer so I don't have to write it every single time, okay? So that, already finished, done, gave me all my yellow answers. Finito. Next, here, this is different. So I'm going to do comma, theta equals. If I start at 7 pi over 6, can I add a certain amount, get here, add that same amount, and get back here? Is this the same size as this?
No.
No. That's when we definitely need 2 equations, not just 1. Here, because it was the same on both sides, we could just do 1 equation. Here, it's not the same between them here and between them here. In geometry, you learned about minor arcs and major arcs, where a major arc was more than a semicircle or half of a circle. So you kind of think of it that way. If they both have a semicircle between them, we can consolidate into 1 equation. If not, we have to write 2 equations. So here I'm going to write plus 2 pi n. And I have to do that one separately. Theta equals 11 pi over 6 plus 2 pi n as well. But all of this is the answer. And this is already written for all of them. Every time I use n, I know it's an integer. If I don't say in my answer that n is an integer, n could be any number then. What if n was 0.5? Well, if I do 2 pi times 0.5, that's 1/2, that will give me pi. And if I add pi to 7 pi over 6, I'll land here. And that's not good. I only want n to be an integer, so I'm adding a full time around, all the way around, okay? So your answer for part B, finding all of our solutions, also known as our general solutions, like a generic plain formula way of generating all of the answers. So general generates a lot of answers for us. That will be our entire solution. And we just cannot forget to say that n is an integer. So you could just write it as a sentence, or you could use that symbol. Do you have any questions about part B for this one, or did you girls get it right? You maybe
we
wrote
don't
this
know.
separate, but it's okay if you did this twice. One for this and one for this with 2 pi.
Yeah.
That's fine. That's okay. But just so you know, it's like a little shorter if you could put it into 1. But it doesn't matter. If you want to leave it as 2, knock yourself out, okay?
And it doesn't matter if I put pi n or 2 pi n.
If you put this one with pi n, that's fine. Or if you did them separately, 2 of them with 2 pi n,
Exactly.
that's also fine. It's the same thing. But this one, we can't put pi.
Okay.
Because like I was showing you here, if I add pi n from here, if I add pi, I'll land here. And that's not an answer. The answer is here. So I have to go all the way around 2 pi and keep going here, here, here every time. And same with this one. But here, I could go halfway because that's also an answer. So pi, 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 pi.
I just can put pi n if pi is in the top.
You could only put pi n if the answers are across the circle from each other. So like here, here, or perfectly across. Perfectly across. And say it again.
We put pi when they are in the same distance.
Away from each other, yes. So if your answers were pi over 6 and 7 pi over 6, then you can use pi n.
Okay.
If it was pi over 4 and 5 pi over 4, pi over 3 and 4 pi over 3, as long as they're always like across from each other, that means they're pi on the left and pi on the right of the circle, like both parts, then you could do plus pi n and make one equation.
Okay.
Okay?
Yeah. So all that we have to do is the part B.
Yes. So that's what we're working on right now. It's taking what we did for part A, and we're just kind of building on those answers and making it into general solutions for part B.
And we have to upload in Classroom? Or
well, let me just, so I'm going to end this video here, this general solutions. So I'll stop recording for that part of the explanation. We'll talk about class homework stuff. But yeah, so these are our general solutions. If you feel pretty good, thumbs up. If you are on that struggle bus, put a thumbs down, and we will do everything we can to make more videos explaining what needs to be done and hopefully help you some more. But I hope that this was helpful.